Welcome to Math Tutorials. In this video, we are solving every question of exercise 4.5 of Chapter 4, Determinants, from the NCERT Mathematics textbook for Class 12, Part 1. Exercise 4.5 has 16 questions on applying determinants and matrices to linear systems, 6 consistency checks, 8 systems solved by the matrix method, an inverse reused to solve its own system, and a shopping word problem. Here they all are. Question 1. We must examine whether this pair of linear equations is consistent, that is, whether it has a solution. Write the system as a x equals b. If the determinant of a is non-zero, a unique solution exists. In matrix form, the coefficients go into a, the unknowns into x, and the right sides into b. The determinant of a is 1 times 3 minus 2 times 2, which is minus 1, non-zero. A non-zero determinant means a is invertible, so x equals a inverse b exists and is unique. The system is consistent. Question 2. Another pair of equations to test for consistency. The same determinant test decides it. Set up the matrix form first. The determinant is 2 plus 1, which is 3 non-zero. So a is invertible and the system has a unique solution, consistent. Question 3. Notice the left sides. The second is exactly twice the first, but the right sides are not in that ratio. Let us confirm with determinants. When the determinant vanishes, the test moves to the product adjoint a times b. Matrix form as before. The determinant is 6 minus 6, 0, so it is singular and we must examine adjoint a times b. The adjoint swaps the diagonal and negates the off-diagonal entries. Multiply the adjoint by b, entry by entry. The result is not the zero matrix. A singular with adjoint, a times b non-zero, means no solution exists. The system is inconsistent. Question 4. 3 equations now, and the third carries a constant in every coefficient. We compute the determinant of the coefficient matrix in terms of the coefficient matrix and right side column. Expand the determinant along the first row, writing each 2 by 2 minor. The minors give 4a, 2a, and minus a, so the determinant equals a. For a non-zero, the determinant is non-zero, a is invertible, and the system is consistent with a unique solution. If a were 0, the third equation would read 0 equals 4, which is impossible. Question 5. A 3 by 3 system with some 0 coefficients. No x in the second equation, no z in the third. We compute the determinant first, and since it will vanish, the adjoint test follows. Matrix form, with zeros filling the missing terms. Expand along the first row, 3 times minus 5 plus 1 times 3 minus 2 times minus 6. The total is 0, so it is singular. For the adjoint, we need all 9 cofactors. Row 1 first. Cofactors of row 2, each with its minor written out. And cofactors of row 3. Transpose the cofactors for the adjoint, then multiply by b. The first entry is minus 10 plus 15, which is minus 5. Non-zero already. Singular with adjoint, a times b non-zero. The system has no solution. Question 6. The last consistency check, a full 3 by 3 system. One determinant decides everything if it is non-zero. The coefficient matrix and right side. Expand along the first row, evaluating each minor. The minors are 28, minus 13, and minus 19, so the determinant is 140 minus 13 minus 76. 51, non-zero. A is invertible, so the system has a unique solution and is consistent. Question 7. From here on we actually solve. the matrix method computes x as a inverse times b. First the setup, then the determinant, the inverse, and finally the product. Matrix form of the system. The determinant is 15 minus 14, which is 1, so the inverse is just the adjoint. Multiply a inverse by b, each entry a row times column sum. Reading off the column, x is 2 and y is minus 3. Question 8. Another 2 by 2 system for the matrix method. This one has fractional answers. The determinant will be 11, and it will appear under both unknowns. Matrix form. The determinant is 8 plus 3, which is 11. Multiply by b. The sums are minus 5 and 12, all over 11. So x is minus 5 over 11, and y is 12 over 11. Question 9. The pattern is familiar now. Form, determinant, inverse, product. Keep an eye on the negative determinant here. Matrix form. The determinant is minus 20 plus 9, minus 11. Multiply by b. The sums are 6 and 19 over minus 11. Dividing by minus 11 makes both values negative. X is minus 6 over 11, y is minus 19 over 11. Question 10. The last 2 by 2 system before we move to 3 unknowns. Both equations share the coefficient 2 on y, which makes the determinant easy. Matrix form. The determinant is 10 minus 6, which is 4. Multiply by b, minus 4 and 16 over 4. So x is minus 1 and y is 4. Question 11. 3 unknowns now, and a fraction on the right side of the second equation. The full 3 by 3 routine. Determinant, 9 cofactors, adjoint, and the product with b. Matrix form. Note the 0 for the missing x in the third equation. Expand the determinant along the first row. 2 times 13 minus 1 times minus 5 plus 1 times 3, which is 34. Cofactors of row 1. Cofactors of row 2. Cofactors of row 3. Transpose for the adjoint, then multiply by b. 13 plus 12 plus 9 is 34. 5 minus 15 plus 27 is 17. 3 minus 9 minus 45 is minus 51. Divide by 34. X is 1, y is a half, and z is minus 3 halves. Question 12. A tidy 3 by 3 system whose answers come out as whole numbers. The determinant is 10, and the cofactors are small. Matrix form. Expand along row 1. 1 times 4 plus 1 times 5 plus 1 times 1 giving 10. Cofactors of row 1. Cofactors of row 2. Cofactors of row 3. Adjoint times b. 16 plus 0 plus 4 is 20. Minus 20 plus 0 plus 10 is minus 10. 4 plus 0 plus 6 is 10. Divide by 10. X is 2, y is minus 1, z is 1. Question 13. Every coefficient is present in this system. The determinant will be 40. The cofactor matrix has a striking first column, 3 5s. Matrix form. Row 1 expansion. 2 times 5 minus 3 times minus 5 plus 3 times 5 gives 40. Cofactors of row 1, 5 5 5. Cofactors of row 2. Cofactors of row 3. Adjoint times b. 25 minus 12 plus 27 is 40. 25 plus 52 plus 3 is 80. 25 minus 44 minus 21 is minus 40. Divide by 40. X is 1, y is 2, z is minus 1. Question 14. The determinant here is only 4, so the arithmetic in the final division is quick. Watch the larger cofactors in the middle row of the adjoint. Matrix form. Row 1 expansion. 1 times 7 plus 1 times 19 plus 2 times minus 11 gives 4. Cofactors of row 1. Cofactors of row 2. Cofactors of row 3. Adjoint times b. 49 minus 5 minus 36 is 8. Minus 133 plus 5 plus 132 is 4. Minus 77 plus 5 plus 84 is 12. Divide by 4. X is 2, y is 1, z is 3. Question 15. 2 tasks. First, invert the given matrix A, then notice that it is exactly the coefficient matrix of the system. So the inverse, once found, solves the system in a single multiplication. Expand the determinant along row 1. 2 times 0 plus 3 times minus 2 plus 5 times 1 gives minus 1. Cofactors of row 1. Cofactors of row 2. Cofactors of row 3. The adjoint is the transpose of the cofactors, and dividing by minus 1 flips every sign. This is an inverse. The system is exactly a x equals b with this a, so x is a inverse times b. Multiply. 0 minus 5 plus 6 is 1. Minus 22 minus 45 plus 69 is 2. Minus 11 minus 25 plus 39 is 3. So x is 1, y is 2, and z is 3. Question 16, a word problem. 3 shopping trips with different quantities of onion, wheat, and rice, and 3 total bills. Let x, y, z be the per kilogram costs of onion, wheat, and rice. Each trip becomes one linear equation, translating the 3 purchases into equations in x, y, and z. Matrix form. Row 1 expansion. 4 times 0 minus 3 times minus 30 plus 2 times minus 20 gives 50. Cofactors of row 1. Cofactors of row 2. Cofactors of row 3. Adjoint times b. 0 minus 450 plus 700 is 250. 1,800 plus 0 minus 1,400 is 400. Minus 1,200 plus 900 plus 700 is 400. Divide by 50. Onion costs 5 rupees, wheat 8 rupees, and rice 8 rupees per kilogram. That completes all 16 questions of exercise 4.5. In the next video, we will take up the miscellaneous exercise on Chapter 4, Determinants. Thank you for watching. If you found this video helpful, do like it, subscribe to math tutorials, and share it with your friends.